All right, ladies and gents, we're going to dive into just a quick overview of some of the probability review 1 stuff. So, you can remember it. We're just going to just hit on a couple of them, a few of them, not a couple. So first one, you're trying to find the number of possible outcomes in the sample space. So we got chess club, deciding when and where to meet. Possible days are Tuesday, Wednesday, Thursday. Times are 3, 4, or 5 p.m. And there's 8 classrooms. So if you're trying to figure out the number possible, well, you got to figure out, how many of the first option there are. 8 times by how many options there are of the second one. So it's 3 days, 3 different times. And then there's 8 classrooms. So 3 times 3 times 8 gives you 72. 3 times 3 is 9 times 8 is 72. The next part, determine if A and B are independent events, showing the appropriate calculation. A few things you can test out. If probability of A times probability of B equals the probability of A and B, then that would be independent. The other one you can test is the probability of A. Is it the same as probability of A given B? Is that the same as the probability of just plain old A? And you can test that. So let's test out number 7 here. We got probability of A given B. Is that the same as probability of A? And this is pretty easy to see that it's not. You got 2/5 compared to 1/2, which is not the same. That's a 0.4 versus 0.5, which is a 10 percentage point difference. So not the same. So these are not independent. What are you going to say? They are dependent. Let's jump to another one. We're going to determine whether it's independent or dependent events and find the probability. We got 5 nickels 3 times and 5 quarters in your pocket. You randomly pick out 3 coins, place them on the counter. First 2 are dimes and the third is a quarter. So this is drawing without replacement. So it's like if you pulled them out one at a time, it'd be the probability of the second one changes based on the first one. And so this would be dependent. The later coins depend on the first ones. The probability of later coins depends on what you got first. So we're going to get this probability real quick. So we need probability of dime, and quarter. So it's going to be probability on the first one of it being dime. Well, there's 3 dimes, and let's see, 5 and 3 and 5. So there's 13 total. So 3 out of 13. And then you're going to times that by the next one, which is going to be dime again. There's only 2 dimes left and 12 coins left. And the last one, you want the third one to be a quarter. There's 5 quarters and 11 coins left. So you get this. So across the top, 3 times 2 times 5 gives you 30 on top. And on bottom, you got 13 times 12 times 11, which gives you 1716 on bottom. So we do 30 divided by 1716. You get about a 0.175 chance here. So that's a not super high chance that would happen. All right, we're going to look at just a couple more, 3 more here. This one, got carrying pages of homework for math and English, and they blow all over the place, and she recovers 4 random ones. So probability she covers all her math homework. Well, this can be solved really nicely with a permutation or combination. The order does not matter, so it's going to be a combination problem. There's 4 that are math, and we want to choose all 4 of them. And on the bottom here, there are 8 pages possible, and we're picking 4 of them. And so here's our setup here. Let's see, let me get this here. Math. First one here, 4 combination 4 comes out to be just 1. And on the bottom, we got 8 combination 4 is 70. So it's a 1 in 70 chance, which is about, let me get this one quick, about 0.143-ish. So that's not a really high chance, about 1.5% chance of getting that. Let's jump down to here. The table's not filled in for you, but if you read the words, you do some adding, subtracting, you'll get these numbers here. But I want to show you this one because I want you to remember what this little symbol means, which means complement or not that group. So the complement of the adults in this situation would be teenagers, and the complement of having used a fidget spinner is not using a fidget spinner, which I'm just going to leave as F complement. So teenager has not used a fidget spinner. So we got those who have not used a fidget spinner, which is 222. And those that are teenagers is 53. Ta-da, that'd be the whole thing. And you can get a decimal approximation for that, which is about 0.2387, like that. And then one last example for you. Department store has a certain situation here. So I took the statements and converted them to these. J is junior, S is senior, F is female, M is male. And it's picking a random student, and you're trying to figure out the probability that it's female and a senior. Well, the probability of that is going to be equal to the probability that they're senior times the probability that they're female given they're a senior. And so I'm going to get that. Probability that they're senior is 0.7. And probability that the female given senior, oh, that's right here already, it's 0.45. So times that. And so when we times them together, 0.7 times 0.45 gives you 0.315. And ta-da, we got our probability there. So yeah, just kind of a wide swath of different things you have to remember about probabilities. If you're not making a note card, you need to make a note card for things like these formulas, how to test for independence. You want to remember how to get your combinations and permutations. You want to remember what complement means. You want to know what these symbols mean, the and symbol, the given symbol. You want to remember these sorts of things on whether things are, how to get probabilities and stuff like that. So get all your formulas, be ready to go. Good luck.